In case of MRI, we have a device which produces magnetic field F, and the whole body is immersed in that magnetic field. Every component of the body receives some effect via this field F. %70 of our body is water, the rest are the other things. Magnet will thus affect this water as well as every other thing. By mass, effect of magnet on the water will be the major effect of MRI on our body, because others are in lesser concentration as compared to water, which has a clear majority. So in proportion of its mass, water will have the greatest effect. So in other words, MRI is the study of how a magnetic field affects the water contents of the various tissues of our body. Water has both electric and magnetic dipole. Just like the presence of a charge and electric field E, force F equal to QE is experienced. Similarly, if there is a dipole D present, if immersed in a magnetic field F, some form of dF, a force proportional to this dF will be felt. In other words, when this MRI machine generates this magnetic field, the water inside our body will feel a force. When the MRI is not working, consider this cell from our body. The water is moving in every random direction. Now when this MRI is switched on, each of them will be put under electric field. They will be forced to align themselves along the field. This MRI gives each of these water molecules some energy E, so that they are forcibly, not by their will or randomly, forcibly they are aligned into this direction. This is a state of tension due to this gain of energy. They are forced to be in this direction. Whenever this MRI is switched off, this electric field is no longer there. This electric field magnetic field is no longer there. They will quickly try to return back to their original position. This was a constricted, restricted, forcible state of uniform alignment. From here, which had gained energy. From here, they will go back to their relaxed state. So they will release energy. This energy is picked up and converted into image. That is what is MRI. Imagine swimming versus imagine running. It is easier to displace gases than to displace liquid. More difficult to displace a solid from inside it. In other words, if MRI gives an energy E to everyone with a force F to everyone, uniform, it will be easiest for the solid components to get more energy, like more quickly energized. For the same energy, it will take lesser time to gain the energy and also lesser time to lose it. Hard substances are difficult to bend. Even if bent by strength, when the strength is released, it will very quickly go back to its original state. Highly elastic. Liquids and gases, on the other hand, are very difficult to, they are very easy to bend or displace. And once displaced, they take a long time to come back. Similarly, these will take a long time to gain energy. Once gained, they will take a long time to release it as well. Suppose this is energy versus time. This, by yellow I am denoting a dense tissue, and by blue I am denoting a light tissue. The dense one will gain energy the same, and if I ensure that MRI is giving a same amount of energy E, the dense ones will quickly gain that energy when the MRI is switched on, and when it is switched off, it will quickly lose that energy as well. Lighter substances, on the other hand, will take a long time to get charged up to that energy, and will take a long time to release it as well. Let us imagine I am again plotting time versus the energy, and this is the maximum energy, uniform in all ways, being given by MRI. This is dense and this is light. At time 0, both of them have 0 energy. Now I switch on the MRI machine. The denser one will quickly gain the energy and remain stable. The lighter ones will take a long time to get the energy and will then remain stable till I turn the MRI off. This is where I started the MRI. This is where I will stop the MRI. Once I stop the MRI, once I stop the MRI, I know that the tissues, be it dense or be it light, will release energy. In other words, after I switch off the MRI, I will be getting my image, because the energy will be released that will be converted into image. So imaging starts from here. Once I switch off the energy, the dense ones will quickly lose it, while the lighter ones will take long time. And then if I start from here and I measure at 1 second, if I start from here and I take an image at 1 second versus I take an image at 2 seconds. If I take an image at 1 second, the yellow means the denser one will have more energy at that point and will appear bright. The lighter tissues will appear dark. That is, in 1 second, the denser tissue will appear bright and the lighter tissue will appear dark. In the second, the lighter tissues will appear bright, denser will be dark. In the second, denser will be dark and lighter will be bright. Using this analogy, we can say T1 wetted MRI, dense fats will appear bright and lighter water and CSF, not water actually, edema or CSF will appear dark. T2 will have dense fat appear dark, and any watery substance like edema or CSF which are lighter will appear bright.